بسم الله الرحمن الرحيم. درس اليوم The Fundamental Theorem of Calculus. The first part of the fundamental theorem of calculus is if f is continuous on AB and f of x is antiderivative of f of x, then the integration from a to b to f of x dx equals to f capital of b minus f capital of a. Let's take some examples to understand this. The first example we have the integration from 0 to 2 x squared minus x dx equals, using the power rule, we'll get x cubed minus 3 minus x squared over 2 from 0 to 2, and this will give us, we first we substitute with 2, we write 2 cubed over 3 minus 2 squared over 2, okay, and then we substitute with the 0, the lower limit, minus 0 cubed over 3 minus 0 squared over 2. This part is equal to 0, so we'll get the this answer and the calculator. Next, we have the integration from 1 to 4 to the square root of x minus 1 over x squared. First, we will apply the rule of the fractional power, where x is raised to half, so we'll get x raised to 3 over 2 over 3 over 2 minus, here we have the x is raised to negative power, which is 2, so we will add 1 and as the following, and then subtract by divide by the new power, which is minus 2 plus 1, and this is from 1 to 4. 1 to 4 coming from the limits of the integration. Okay, let's substitute, let's make it more easier to substitute in, writing 2 over 3 x raised to 3 over 2 minus plus x raised to minus 1, and this is from 1 to 4. First we substitute with 4 and then we substitute with 1 as the following. We write 2 over 3 multiplied by 4 raised to 3 over 2 plus 4 negative 1 minus, substituting with 1, 2 over 3 plus 1 equals, and then use the calculator to get the answer. After that we have here e raised to minus 2x integrated from 1 to 4. This integration needs to be multiplied by negative half from outside and negative 2 from inside, e negative 2 of x dx from 1 to 4. Why to multiply by negative 2? Because it is the f dash of the power of the e, okay, and this will give us minus 1 over 2 multiplied by e minus 2x. The integration from 1 to 4 equals, we first substitute with 4 and then subtract the substitution with 1. Okay, so minus 2 e raised to minus 2 multiplied by 4, which is 8, minus e raised to minus 2 multiplied by 1, which is minus 2. Okay, next we have the integration of 2 over x from minus 3 to minus 1. 2 is a constant coefficient, so it goes outside the integration. We have 2. The integration from minus 3 to minus 1, 1 over x dx. We get 2, the integration of 1 over x is ln x, okay, from minus 3 to minus 1, and this will be equal to ln the absolute value of minus 1 minus ln the absolute value of minus 3, and this will give us 2 ln 1 minus ln 3, where ln 1 is equal to 0, so it's equal to minus 2 ln 3. Okay, next, part 2 of the fundamental theorem of calculus. If f is continuous on the interval ab, f of x, the capital F of x, is equal to the integration from a to x f small of t dt, then the f dash of x is equal to the f of x itself on the interval ab. So if we want to get f dash of this integration, we just write the function inside the integration with respect to x, and a can be any constant. Let's try this in these two examples. We have f of x equal to 1, the integration from 1 to x to 12t raised to 5 dt, get f dash of t. The upper limit is x, lower limit is 1, so f of t in this question is 12t5, okay, so f dash of x will be equal to f of x, which is 12x raised to 5. So in this example also is the same. We have the upper limit is x, lower limit is constant 1, and they want the f capital dash of x, and we have this function f of t equal to t squared minus 2t plus 3, so f dash of x will be equal to x squared minus 2x plus 3. Next, use fundamental theorem part 2 and the chain rule. Here we need the chain rule because of the upper limit. The upper limit become x squared, not x. We have f capital of x equal to the integration from 2 to x squared cosine t dt. Compute f dash of t. We have f of t equal to cosine t. Okay, so f dash of x will be equal to cosine x squared. We substitute with the upper limit of the integration multiplied by dx squared over dx. Okay, and we know that the derivative of x squared is 2x, so 2x cosine x squared is the answer. Next, an integral with variable upper and lower limits. Here we have the variable in the upper and the lower limits of the integration. So we will make use of this property of the integration as following. We have the integration from a to b to something d of x, okay, is equal to the integration from a to c of something dx plus the integration from c to b of something, where c is inside the interval ab. Okay, so what we will do is divide f of x into two parts, okay, and then make the also we need the following property, which is the integration from a to 0 of something dx equals to minus the integration from 0 to a to the something dx. Okay, so let's use the first one and then use the second one. F of x can be divided as following: 2x to 0, the square root of t squared plus 1 dt plus the integration from 0 to, so our c here is 0 to x squared, the square root of t squared plus, sorry, f f of f of t, no, it's fine, I'm sorry, it's right, sorry, dt, and this will be equal to, now we will we have the constant here is 0, but here the constant in the upper limit, so we will use the second property, get the minus outside and flip the limits of the integration. So we will get minus the integration from 0 to 2x, the square root of t squared plus 1 dt plus the integration from 0 to x squared, the square root of t squared plus 1 dt. Now f of x is divided into two pieces, and each piece can be applied, we can apply easily the part 2 of the theorem, okay, as following. We write f dash of x equals to, first our f of t is the square root of t squared, and f of t also here is t squared plus 1, but the upper limit is 2x, so we will substitute with 2x instead of t. So 2x squared plus 1, and then we'll use the chain rule, d over dx to 2x plus the square root of, we have here t squared, we have the upper limit is x squared, so x raised to 4 plus 1, using the chain rule again, d over dx to x squared, and then you can substitute this by just evaluating the answer of d over dx. Here of 2x is 2, and here dx squared over dx is 2x. Okay, and then you will get the answer. I hope you get this one. Next, rate of change and total change of volume of a tank. Suppose the water flows in and out of a storage tank. Okay, the net rate of change, that is, the rate is minus, and the rate out of water is f of t. So f of t is what? Is rate of change of water, and it is equal to 20 multiplied by t squared minus 1 liters per minute. Okay, A, for the following interval from 0 to 3, determine when the level of water is increasing and when the level of water is decreasing. Okay, first of all, we will write t, and we will write f of t. Okay, t is 0, 1, 2, 3, because the interval from 0 to 3, so we will substitute in the function f of t equals to 20 multiplied by t squared minus 1 with these numbers to see when it's positive and when it's negative, to know when the water level increasing and when the water level is decreasing. So when t equals 0, here is negative 20, so it will be negative. So when t is 1, we have 1 minus 1, so it's gonna be 0. So in this interval it is decreasing. Okay, if we substitute with 2, 2 minus 1 is positive, which is 1. It will give us 20, which is positive, and then 3, substitute with 3 squared minus 1, it will give us 8, and then 8 multiplied by 20 will give us positive number. So in this interval it is increasing. Okay, so let's write it here, f of t on the interval from 0 to 1, it is decreasing, and f of t on the interval from 1 to 3, it is increasing, where these intervals are the time. Okay. B, if the tank has 20 liters of water at time t. Okay, so we will write that W of t is the water, or the liters of water at time t. Okay, so we can write the following. There is 20 liters of water at time t equals 0, so according to what we consider, we can write W of 0 equal to 200. Okay, determine how many liters of water are in the tank at time t equals 3 minutes. So when t is 3, what is W of t? Okay, now we know that W dash of t is rate of change of water at time t, which is equal to F of t, that is equal to 20 multiplied by t squared minus 1. Okay, let's integrate both sides. So integration of W dash of t dt equals to the integration of F of t, and we have at time t equals 0, and we want at time equals 3, so we will integrate from 0 to 3. Okay, now this dash will go with this integration because the derivative go with the integration, and we will get W of t, the integration from 0 to 3, equals to the integration from 0 to 3 to 20 t squared minus 1 dt. Now let's integrate this part using power rule. We will get 20 outside the integration because it's a constant coefficient. T raised to 3 over 3 minus t from 0 to 3. Okay, and on this side we will substitute with 3 and then substitute with 0. So we will get W3 minus W of 0. Okay, and now we will get W of 3 equals to W of 0 plus what? Let's substitute here with 3 equal to 0. I mean t equal to 0 and t equal to 3. We will get 20. 3 raised to 3 over 3 is 3 squared minus 3. Okay, minus 0. Okay, because when we substitute with t equals 0 here, it will be 0, and here will be 0 again. So we have here 9 minus 3, which is 6. 6 multiplied by 20 will give us 120. So we will write 120. W of 0 is 200, so 200 plus 120, this will be equal to 320, and this is the answer of B that we want to reach to. Next, find a tangent line for a function defined as an integral. They give us a function f of x. This integration from 4 to x squared to ln t cubed plus 4 dt. Find an equation. They want the equation of the tangent line at x equal 2. So the equation of the tangent is the slope m equal to y minus y1 over x minus x1, where x1 is equal to 2 because they want it at x equal 2, so m equal to y minus y1 over x minus 2. So what we need from here is to get the m and to get y1. How to get y1? We have the function here y, so y1 equals to f2, which is equal to the integration from 4 to 2 squared, which is 4 ln t cubed plus 4 dt. So when we integrate at the same point 4 to 4, we will get only 0. So we have here y1 equal to 0, so m equals to y over x minus 2. So we can write y equals to m multiplied by x minus 2. Now we need the m. How to get the m? We have the function here. We want the equation of the slope, which is f dash of x. So f dash of x we will use the part 2 theorem of the calculus that we used. We have here the upper limit is x squared, so we will take f of t, okay, where f of t equals to ln t cubed plus 4. We can write that f dash of x equals to ln x cubed, because we take each t and put x squared, so we will write x squared cubed plus 4, and then using the chain rule, which is d over dx x squared, and this will give us we know that the derivative of x squared is 2x, so 2x ln x raised to 6 plus 4. Now we know that the slope is f dash of 2 because it is at x equal 2, so this will give us 2 multiplied by 2, which is 4 ln 2 raised to 6 plus 4, and this is equal to 4 ln 68. So we get now the slope. What we need now is to just substitute here with the m, and this is our answer. So y equal to 4 ln 68 multiplied by x minus 2. Next, computing the distance fallen by an object. Suppose the velocity of a skydiver is given by the following. So we have velocity vt equal to 9 1 minus e minus t. Okay, for the first 5 seconds, i.e. t from 0 to 5 of a jump, compute the distance fallen. So we have velocity and we need the distance. We will just integrate to get the distance. Okay, so we get the distance, let's call it dt. Okay, so dt equals the integration from 0 to 5 because it's the first 5 seconds. 9 multiplied by 1 minus e minus t dt, and this is equal to, we get the 9 outside the integration because it's a constant coefficient, so 9, the integration of 1, which is t, and the integration of minus e raised to minus t is plus e minus t, and this is from 0 to 5. We substitute with 5 and then we subtract this with the after we substitute with 0. Okay, so 9 5 plus e minus 5 minus 0 plus e 0, and this part will give us 1. So 5 minus 1 is 4 plus e raised to minus 5. We can evaluate this using the calculator, okay, to get the distance. Or in general, you can say that this is the distance with meters. Okay. تم بحمد الله. Thank you all for listening. I hope you can share me your thoughts about these videos or ask me any questions.